Hey class, in this video what we're going to be looking at is how to solve systems of equations using a technique called elimination, sometimes called the addition method. This is 5.3 in your textbook and 5.3 in your packet of practice. So let's look at an example here. We're going to use addition to solve this system. So why don't you pause the video and write the problem down in your notebooks, and then follow along as I go through it. Okay, so we're going to use addition to solve this system, also called elimination, because our whole goal with this technique is to eliminate a variable. This one is set up, if you look at this, this is when you're going to want to use this system. Notice that the x's are in line here. We've got our x terms in line, our y terms are in a column, and then our constants are in a column here. So this is why when you would want to use this method is when they're lined up like that. So what you do is you simply add the columns. These numbers right here in front of the x, which is this whole -2, this is +2, this is 3, and this is 5, those are called coefficients. And in this particular case, your coefficients on the x are exactly opposite, which is what you want when you're using this method. You want to make the coefficients in front of one of the variables exactly the opposite. Here's why. Now when I add this column, what do you get? What's 2x minus 2x? That's 0. Don't even really need to write it, but I will, just for fun. And the next column, when I add that up, 3y plus 5y is 8y. And then when you add your constants, we get 24. So we end up with 8y is equal to 24. How do you solve that for y? You are correct. We divide by 8 and you get y equals 3. Not done, because remember, when you're solving a system of equations, if there's one solution, it's going to be an ordered pair. So we have our y coordinate, now we need to find x. So what we're going to do is plug this value of y into either equation 1 or equation 2. I'm going to pick equation 1 because all of the numbers there are positive. So I'm going to write 2x plus, but I know y is equal to 3 in the solution. So I'm going to put that in place of this y right here is equal to 11. So I'm writing this complete equation, but I'm throwing in the fact that I know y is 3 in for y. Then I'm going to solve. So I have 2x, 3 times 3 is 9, equals 11. And you should pause the video, try to solve it on your own, and then check the solution. We're going to subtract 9 from both sides. And we have 2x plus 0, don't need to write it, equals 2. And then our last step here is to divide by 2. And we get x equals 1. So our solution to this system is, remember it's an ordered pair, so it's important to write it in order, 1, 3. And hopefully you recall how to check to see if it truly is a solution, which you should be in the habit of doing. You can check it in equation 1. So this is my check. Equation 1, if I throw in 1 for x and 3 for y, does it equal 11? And we get 2 plus 9 is 11. That checks out. Let's do this for equation 2 as well, because remember, if it's a solution, it has to be a solution to both of the equations, not just one. All right, so -2 times 1 plus 5 times 3, does that equal 13? Question mark up there. So -2 times 1 is -2 plus 15. -2 plus 15 does indeed equal 13. So that is a solution. Okay, next problem. Let's pause the video again, write it down. In this particular problem, in equation 1, our coefficients are 4 and 3 in front of x and y respectively, and we have 5 and 3 for the second equation here. They're not exactly the opposite. So what we need to do is we need to figure out a way to make them exactly the opposite. I've got a 3 and I've got a 3. I need one of them to be a -3. So what I'm going to do is I'm going to pick one of the equations, and it doesn't matter which one in this case, and I'm going to multiply it by -1. I'm going to rewrite this top equation, 4x plus 3y equals 2, that's an equal sign. And I'm going to multiply the second equation by a -1. And as long as you do it to both sides, it's completely legit. I get -5x minus 3y equals +2. Multiplying by a -1 just changes the sign on both sides of the equal sign. Now, if you notice, I have a 3y in the top equation, I have a -3y in the bottom equation, which means I can eliminate y when I add these together. So you're going to add straight down, and you can only add like terms, remember. So 4x and -5x is -1x, which you can write as just -x. This next column is 0. I'm not even going to write it. And I get 2 plus 2, which is 4. So that's really a -1x. So if I want to get rid of the negative, I can divide both sides by -1. And I get x is equal to -4. All right, now pick one of the two equations, put in -4 for x, and solve for y. You guys do that on your own and come back to check to see if you got it right. I'm going to pick equation 1. 4 times -4 plus 3y equals 2. Now solve for y. This is -16 plus 3y is equal to 2. Add the 16 because it's a -16. And I get on the left 3y, and on the right 18. Divide by 3, divide by 3, and I get y is equal to 6. And you should check your solution by plugging in -4 for x and 6 for y. But I want to do one more problem, so I'm going to, you check it. It should work. I'm going to skip this one for now, and I'm going to do one. I'm going to do this example. This is example 3. All right, if you look, we have a 2 in front of the x on the top and a 5. And we have a 3 and a -1 in front of the y's. So I want you to stop and think, what variable would be easiest to eliminate, and then what would you have to multiply by? If you look, I've got a 3y and I've got a -y. If I multiply equation 2 by 3 on both sides, I'm going to have a 3y on the top and I'm going to have a -3y on the bottom. So just rewrite equation 1, and writing equation 2, after multiplying by 3, I get 15x minus 3y equals 13 times 3 is 39. Now my y's are going to drop out when I add here. So this column is 17x, 2x plus 15x is 17, 3y minus 3y is 0, and 2 and 9 is 11. This is 51. 17x equals 51. Divide by 17. Divide by 17, and we get x is 3. Put that back in for y. I'll pick equation 1. You guys do it on your own and check the answer. I get 6 plus 3y equals 12. Subtract the 6. And we get 3y equals 6. Divide by 3. Y is 2. So, my solution, again, be in the habit of checking it, is 2, comma, up. What did I do wrong? I put the y coordinate first. It should be 3, comma, 2. And that's a wrap.